What's that nuclear symbol all about worksheet? Please have your worksheet up so you can annotate or print it off so you can write on it. Pause the video if you need to do that. Please fill in your missing notes. Pause as needed. Again, pause as needed. This is a mnemonic device. It is in efforts to help you remember something. Please remember this is just to help you remember. I'm positive you're a loser. This is to help you remember that if the charge is positive, then the atom has lost electrons or loses electrons. I'm positive, you're a loser. So when you have a positive charge, it means you lost electrons. You have less electrons than you have protons. Okay, I will do these 6 examples with you, and you are expected to have these examples on your paper yourself, and then you can complete the rest from my examples. So here we have sodium. We don't know if it has a charge or not. We're going to establish that. It has a mass number of 22 and an atomic number of 11. Remember, Miss America, mass numbers on top, atomic numbers on the bottom. So we always know that if we know the atomic number, we also always know the number of protons. They're always equal. Protons and atomic number are always equal. Now, we don't know if this has a charge. We have to establish that by looking at protons and electrons. Because I have equal number of protons and electrons, there is no charge. So on this worksheet, you're going to scratch out the charge so that I know you are aware of that. To get neutrons, you're going to subtract these two things. You're going to take the mass number minus the atomic number, and you're going to figure out then how many neutrons you have. So 11. Here we have a +1 charge. We already know because the mass and atomic number, the atomic number 3 is always the same, always for the protons. Because we have a +1 charge, I'm positive you're a loser. A plus charge means we lost one. So when we have 2 electrons, we had 3 because we had equal, but we lost one. Positive you're a loser. Therefore, it's only 2 electrons. We're going to turn this into a subtraction problem to get my neutrons, 7 minus 3. And then this has a charge of 1 plus. Here we have an unknown charge. If we even have one, we know that we have 16 protons and we have 18 electrons. So therefore, we know we have a -2 charge because we have more electrons than protons. And we're going to subtract these two. So we're going to take 33 minus 16, and we're going to get 17 for our neutrons. We're also going to replace the question mark with a 2 minus as the charge. Okay, here, next example, we have 8938 SR. We have 36 for our electrons, and we know our protons are 38 because our protons are always the same as our atomic number. So we have more protons than electrons, so it's going to be a positive charge, a 2 plus. And you can always go back and say, okay, I'm positive you're a loser. I had 38, I lost 2. That's how I got to 36. And I'm going to subtract 89 minus 36. Let me try that again, I apologize. 89 minus 38. 89 minus 38 is what I meant to say, and we have 51 for our neutrons here. Example 5, we have a -1 charge. We have 17 for protons, and then we're going to take the fact we have a -1 charge and say, therefore, we have more electrons because it's negative than protons. So I have an 18 for my electrons, and then I'm going to take 36 minus 17, and I get 19 for my neutrons. Last example, I have 12 for my protons, and I have 12 for my electrons. Therefore, it has no charge. I'm going to scratch out the question mark saying that it does not have a charge. And then I'm going to take 25 minus 12, and I get 13 for my neutrons. Make sure that these are on your worksheet that you have, and then you can complete the rest of the 30 for your assignment for today. Thank you.